again, ladies and gentlemen. This is Mrs. Conway to go over numbers 6 through 8 in your quadratic review packet. So we're going to start with number 6, which is 2x squared minus 8x equals 5. Remember that we have to have our equation equal to 0 in order to be able to solve it with the quadratic formula. So we are going to first subtract 5 from both sides, which leaves me with the equation 2x squared minus 8x minus 5 equals 0. Okay, now I am going to identify A, B, and C. So A, B, C. A equals 2, B equals negative 8, and C equals negative 5. Plugging it into the discriminant, remember the discriminant is B squared minus 4AC. So B is negative 8, so I'm going to take negative 8 squared minus 4 times A times C. If I evaluate that, I will get 64 plus 40. Therefore, my answer is 104. And since my discriminant is positive, the nature of my solution is two real solutions. When it asks you for the actual solutions, you want to now plug all of this into the quadratic formula. So you are going to use negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you know the little Pop Goes the Weasel song, you can kind of sing that in your head in order to evaluate this. So I'm going to take the value of b, which is negative 8, and take negative 8 plus or minus the square root. You've already evaluated b squared minus 4ac. Right here was 104. So I'm not going to redo all of that work. I'm just going to plug in the square root of 1 over 104 and 2 times a, which is 2. Now it's just a matter of simplifying. From here you can simplify the radical and keep your answer in terms of radical, or you can evaluate it for 2 decimals. So either way will work. But you're going to have 8 plus or minus the square root of 104 over 4. Now you're going to split that up into your two equations. So you have 8 plus square root of 104 over 4 and 8 minus the square root of 104 over 4. If you do 2 decimal approximations, so if you want to simplify the radical, you can go ahead and do that, or just evaluate both of those. So 8 plus the square root of 104 over 4 is equal to 4.55, and 8 minus the square root of 104 over 4 is equal to negative 0.55. So your two solutions for this quadratic, which is number 6, is going to be two solutions of x equals 4.55 and negative 0.55. For number 7, notice it's already equal to 0, but we are missing the x term of this quadratic. So therefore, since it's not there, a is going to be equal to 5, b is now equal to 0 because there is no x term, and c is equal to 125. Evaluating that for the discriminant, b squared minus 4ac, would give you 0 squared minus 4 times a times c. And 4 times 5 is 20. 20 times 125 is negative 2,500. Since the discriminant is negative, I know the nature of my solutions is two imaginary solutions. So now I'm going to go ahead and find my solutions to this quadratic. And to do that, I am going to go ahead and erase this previous problem so it'll give me some room to work for my solutions to the second one, to number 7. So since I have two imaginary solutions, I'm going to go ahead and plug it into the entire quadratic, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So when I plug that in, it's going to be a negative 0 because b is negative. That really will end up just canceling itself out. I really don't even need that 0. Plus or minus the square root. I've already evaluated the discriminant, so I'm just going to go ahead and plug that right in underneath the radical. all over 2a. Now I'm going to simplify. Remember, I don't need that 0 squared, so now I'm basically down to plus or minus. If I simplify the square root of negative 2,500, the square root of 2,500 is 50. Since I have this negative here, that means when I pull out that negative, that becomes an imaginary 50i. So I have plus or minus 50i over 10. So I have two solutions now. I either have positive 50i over 10, or I have the negative 50i over 10. And I can now simplify both of those. 50 divided by 10 is just 5i, and now I have negative 5i. So those are my two solutions for number 7. Number 8, again we're going to go, it's already equal to 0, so I can right away pull out a equals, b equals, and c equals. A equals 1, b equals negative 6, and c equals positive 10. So that means that it's going to be b squared minus 4, again evaluating that b squared minus 4ac, times a, which is 1, times c, which is 10. So I have 36 minus 40, which means that my discriminant value is negative 4. Again, since it's negative, just like in number 7, the nature of my solution is 2 imaginary. Now I'm going to use that quadratic formula right here to plug in and evaluate the entire thing. So the quadratic formula is negative b plus or minus the square root of, well, we already did b squared minus 4ac, so we actually don't need to evaluate that. We can plug in that negative 4 right away, all over 2a. Negative negative 6 gives me a positive 6, plus or minus. What is the square root of negative 4? Well, that negative under the radical means I'm going to have an I, and the square root of 4 is 2, so 2i, all over 2. Now I have two solutions. I can either have 6 plus 2i over 2, or I can have 6 minus 2i over 2. If you simplify those, that will leave you with, notice that 2 is a factor of all of these numbers, so if I divide everything out by 2, I'll have 3 plus I over 1, so it's just really 3 plus I, and 3 minus I. So you have two imaginary solutions. And this concludes the explanation for numbers 6 through 8. Feel free again to rewind and replay this as many times as you need.